In this video, we'll finish talking about rational functions by talking about slant asymptotes. So before, we saw that when the degree of the top is greater than the degree of the bottom, we don't actually have a horizontal asymptote. But it's not really true that we had no asymptote, because really something far more interesting is happening. Namely, if we were to use long division on here, which we can do because the degree of the top is greater than the degree of the bottom, we would have that this is 1, so 1, -1, 0, and our division is by 0, -1, -1, -1, and -1 is -2, +2, and 2. In other words, what you would have is you would have x minus 2 plus 2 over x plus 1. But what that means is, but notice that as x gets really, really large in the positive or negative directions, 2 over x plus 1, the bottom gets large, and so this goes to 0. In other words, the graph is going to start so f of x will tends toward x minus 2. Namely, if the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph of the function has a slant asymptote. So, why do we call it a slant asymptote? Well, let's see this by example. We're going to do this problem similar to what we did before. Again, we can go through and factor the top and bottom. If we factor the top and bottom, we have the top factors as x plus 1 and x minus 2 over x minus 1. Namely, we expect we can do our x-intercept and our y-intercept. The x-intercept is going to be at x equal -1 or 2. The y-intercept, plugging 0 in, will give us -2 over -1, so +2. If we plug in, and then if we check our vertical asymptote, since nothing canceled, there's no holes, but vertical asymptote, we'll have x equal 1 as a vertical asymptote. And horizontal asymptote, because the degree of the top is greater than the degree of the bottom, we have none. But we do have a slant asymptote, because if we do the division, we see that f of x equals, do the division out, so we would have 1 here, and then we'd have 1 minus 1 and -2. And so the 1 comes down, 1 and 1 is 1, 0, 1 and 0 is 0, -2. So we end up with x plus 0 minus 2 over x minus 1. And so our slant asymptote is y equal x. Well, let's go ahead and draw that. Y equal x is this line. Okay. We also have a vertical asymptote at x equal 1. And we have a y, we have a y-intercept at 2, and a x-intercepts at -1 and 2. Well, when x is 3, what happens? We plug 3 in, we get 3 squared minus, so let's go ahead and make a little table down here. I want that out of my way. I want y equal x down there. Okay. Let's see here. 1, 2, 3, 4. So let's do f of x. So 1, 2, 3, 4. -4, -3, -2. We know what happens at -1, 0, 1, and 2. So then 3, 4, and 5. Let's see what happens there. Plugging -4 in, we get 16 plus 4 minus 2 on top, which is 18. 18 divided by negative 5, so 18 over 5. Negative 18 over 5, sorry. Plugging negative 3 in, we get negative 3, we're going to get 9 plus 3 minus 2 is 10. 10 over negative, clear, divided by negative 4 is negative 2.5. Plug negative 2 in, you'll end up with what? Negative, you'll have 4 plus 2 is 6. 6 minus 2 is 4. 4 over negative 3, so negative 4/3. Plugging 3 in, you'll end up with 9 minus 3, which is 6. 6 minus 2 is 4. 4 over 2 is positive 2. Plugging 4 in, you'll get 4 minus, you'll get 16 minus 4 is 12. 12 minus 2 is 10. 10 over 3. And then finally, you'll get 5. Plugging 5 in, you get 25 minus 5 is 20, minus 2 is 18. 18 over 4. 18 over 4 is 9 over 2, or 4.5. So let's graph this. Negative 18 over 5 is what? That's about negative 3 3/5. So 1, 2, 3. 1, 2, 3 3/5 will be about here. More like there. About there. Okay. 3 3/5 is about there. If we go ahead and we plug in negative 2.5 for 3, so 1, 2, 3. Oh, sorry, that was at 4, so that's about there. Sorry. 2.5 is here, so we have that. At 1, we got negative 4/3, so 1 1/3 is about that. It's more like there. Ugh. There you go. Four thirds is about there. In other words, what we have is we get this on this side. We know it's going to go up like that. But as time goes on, it gets really, really close to this line. That's what we know, because it tends toward that line. That's what it means to be a slant asymptote, is you have a slant in the graph, that asymptote. Here, 2, so at 3, we're at 1, 2. There, then we're at 10/3, so that's 3 1/3. 2, 3, which is about there. And then we're at 9/2, so 4/5. 1, 2, 4.5, I mean. 3, 4.5 is about there. About there, you mean. 1, 2, 3, 4.5 is about there. Okay. In other words, as time goes on, it's going to get close to that. And it's going to get close to this. All right. So it looks roughly like that. And now it's once again time for you to try an example. So go ahead and sketch the graph of f of x equals 3x squared plus 2x plus 1 over x. On the count of 3, I'll reveal the solution. 1, 2, 3. So this would roughly be the solution to it. Again, Desmos is great for this sort of thing, but it's still nice that you can analyze this on your own. For more practice in graphing rational functions with slant asymptotes, be sure to see pages 175 and 176 of the textbook and work problems 4 and 47 through 60. In our next video, we'll start talking about polynomial inequalities.